We've been talking about the application layer and application layer protocols all semester. And so I want to give you mainly a demo today and show you what uh, what this really looks like. So, but first, when we talk about the application layer, we want to remember where it is in the reference chain and in the reference model. So you have this is a good example of the network stack at both ends of the connection. And so here we are at our network layer where the IP address is placed on the packet and it's delivered. At the transport layer, this is where we actually utilize the protocol, whether it's UDP or TCP. But mainly, it's in the case of application layer, it could be either one that we use. But this session and presentation layer is where other services take place, like, for instance, doing some encryption, if I encrypted data, or if I have to get the data ready to be presented to the application, if I have to do some task to it, encrypt it, uncompress it, that type of thing. That had to be done before it gets to the application layer. But here's the question. What is that application layer? So what is that really? And we want to think about that because if you're not really sure what that is consists of or composed of, it's easy to get the application and the application layer confused, especially in the application layer protocol. So I'm going to get a list here going of what those are. So if we were using an application, we might use Google Chrome, maybe to browse the web. In our in-person class, someone mentioned, well, what about Steam? Okay, the game delivery system. Okay, what about Steam? We'll look at Steam, and then we have maybe Safari, right? Okay. And now that's going to be a lot like Google Chrome. I'm going to throw in one here. What about an Outlook? Right? Or just a general email client. Email, okay? And then we have, I'm going to use Putty. We're going to look at Putty. You can spell it Putty with big TTY, okay? A little TTY. Putty is there. And then another one here, I'm going to put a dig and nslookup. And we'll put an FTP. Okay. So these are all applications, right, that we might use. And if I have a web browser and I go and I actually utilize it to show me a web page, which I will do, and I'll just look here and we'll go ahead and do a Google search, right? MSN search. I'm going to look at MSN and see all of the data that's transferred. You see my web browser is actually, after it gives me the ad to use Microsoft Edge, it's going to load up all of this content into the browser. Now, so this is actually my presentation layer and session layer at work that are delivered to my browser, which is the application. Delivered it some data, and that is not what you see here. Okay, I'm going to show you what that looks like. We're going to go over here to the developer tools. We're going to click on the source tab. Now this page is still transferring data, right? It is very much transferring data. It's got the JavaScript here. Um, there's so much JavaScript in this page that it's hard to figure out what is the actual uh, page itself. But we'll look at Google and we'll look at its actual index page. Okay, here's an example of this is not just loading up a bunch of Java. It's actually just loading up an index page. But if we look at that and you see what it looks like, now it's not all beautiful and easy to read, as if it were broken out into parts. It's all kind of run together. But it is, you are looking at the actual code that's HTML here. So, but how is it that I get my code over the wire, right, between one place and the next? And um, I have to use another protocol in order to communicate with the web server itself. So there is a protocol that we use between applications, right? And that is what our web browser uses, HTTP or HTTPS. Right? And we can see that when we look at this. In the old days, when you looked at the website address, you would have the HTTP available there, HTTP :// right, www.google.com. So now we have the secure HTTP. This is just when we add security onto this, we're not adding it right here at this point. We're adding it inside the session layer, right? I'm adding a total global encryption. So I'm using an encryption certificate to encrypt my here's my certificate. I'm using my certificate to encrypt the data, and that's something that my browser negotiates and stores for me. And then I can encrypt the data, but I still have to get that payload from the web server back to my server. And so the HTTP protocol is what accomplishes that. And also, if I'm going to put in another thing that this web browser does is it actually utilizes the DNS protocol. There's not, when I put in a website, right, and I put in Google, one of the first things that I'm going to do is a DNS lookup. I don't do it, my browser does it. And that's part of the service that runs on the browser is there's a DNS query right there that comes out of that browser. And what we can do is we can prove that. I'm just going to go to my Ethernet interface, and I'm going to look for DNS in the traffic, and I only want to show DNS. So what I will do is I'm going to, because I have this in my cache, in my local cache, if I go back in there and try to go to that website, it's not going to work the same way. So I'm going to go to one that I haven't been to. We'll go to legoland.com. We'll try and find it anyway. And we got there. But look at that. So this web browser actually went out and did some DNS queries for us. And we probably had to do some different things in order to get that to come up. It took a little bit. It probably wasn't in the cache, both in the PC or the DNS server. So anyway, it took a few requests to get that back. And we can look it up, and we can see here. It's running Google Analytics on its site. Here's Legoland, right? Here's my record. And when I expand that record, I'm going to get the actual name of the server, right? And then it points me in the direction of the next one, right? So it's going to say, oh, we'll go to that one. And it's going to say, oh, go to this field. Oh, go to that one, right? Go to that one. Eventually, I'm going to get an actual address that I can send my request to. And so when I looked up that part -029.t-00009, right, I ended up getting two answers. So ultimately, in this case, it's two different IP addresses. If you notice, the two IP addresses that I was given eventually were different numbers. And so I'll go ahead and use the first address to send my request for the first part of the web page. And so that's the process that took place when I actually did that. So DNS is another application layer protocol. That is something that my browser is running. I'm not running a special DNS application here. I'm just running a browser. Okay? Safari is the same way. HTTPS, DNS. Steam is actually really the same way. Steam is basically it's another web browser, except it doesn't just allow you to browse the web. It just transfers. It's a file manager, so it both presents to you a catalog of games to download, like it was a website. It also downloads that data, checks its integrity, installs the games, and allows you to have the front end to play them. Okay, so but it's basically a web browser. There's not a lot more to it than that. So as you can see, I have protocols that are used at the application layer, and then I have applications. Right, so I could go and write an application and make it look completely different, as is the case of these three things. But notice they're all fundamentally the same inside. Now your Outlook email is a little bit different. All right, so I could use a couple of different protocols there. I can use the post office protocol, the simple mail transfer protocol, or the internet mail and application protocol, IMAP. And we're going to look, when we look at this, we're going to look at, we're going to do a little demo of IMAP. And I'm also going to show you FTP, right? And so, but we'll continue looking at our applications. So Outlook email, If I wanted to have another one that's similar, I could say Thunderbird, right? That's a Mozilla email application, right? I might even say Mutt if I'm on Unix, or Pine if I'm on, we'll just say Pine. Pine is a Unix email program, right? And all of the things that I can do with that is I can use POP, which is an application layer protocol. I have got to communicate. So here's the other idea, right? This server uses this protocol. Okay, so it all uses that protocol. So Steam, same thing. Steam uses Safari. Now Putty, what does it use? We're going to take a look at Putty real quick. Putty, if you haven't had a chance to really look at this program, it is complex. There's a lot of stuff there. But ultimately, everything boils down to this interface right here. I need to connect to a host that is a place for its IP address. It may be local, it may be remote. And I'm going to use some protocol to do it. Now, normally, and the default is Secure Shell, SSH. That protocol is so well known and well used, it has its own port number, 443. Okay, that's for web, SSL 443. For SSH on just a telnet connection over SSH, it's port 22. When I go to telnet, it's port 23. That's another protocol that can be used by Putty. And then notice we also have our login. Notice that port changes to 513, remote login. And then I have a serial connection, and actually some of my other Putty versions will have other protocols that are available. But these are the three main protocols they use for Putty, and there are different. There are totally different rules for using each protocol. But Putty is the application. The application layer protocol is SSH, Telnet, or RLogin. Now another one we have is dig or nslookup. So I'm going to go put my uses here. It uses, and this is just DNS. If I go into my command prompt, I'll just do that real quick because I can. I'm going to use the program nslookup. Now, you see dig there. Dig is the Linux command. On some systems, it may or may not be installed, but if you go into Linux and you type dig, I'm going to do that too. Dig. Okay, so what I do, this is, yeah, so here is my DNS, right? And what I'm really showing you here is that dig knows how to get the root name servers, and these are the ultimate authority for the whole internet. Ultimate authority for the whole internet using any one of these name servers. But so I'm going to say so when I use dig, I can actually tell it what name server I want to use. I'm going to use Google. And I'm going to go ahead and say, well, let's see, what is Google? All right. And we get the format in a little bit different way. But what I have is here, I have data that, remember, dig is my application. The parameters that I'm passing my application are the name server and the lookup. This is my question, right? Question section, google.com. And then I get an answer, right? And notice that my answer is authoritative, and that's the IP address that I would use. And if I have another application, I just pull that right out of the packet and I start using it. nslookup is a little bit different. So I'm going to tell it that I want to use the server 8888, and I'm in interactive mode. So now it says, okay, I'm going to use that server. And here we go. Now look at here. This is actually giving me the same IP address for Google as the other one. However, one thing that is the difference in the two is that nslookup also returned an IPv6 address. Right? It returned an IPv6 address. nslookup dig did not, but I could easily turn that on. That's a configuration of the application itself. What gets me the underlying data is the protocol. So now, because I'm filtering DNS traffic and I'm still capturing traffic, what we can see here is that I send a request to Google. Here's my DNS packet. Once I unpack this thing and I get to that layer 4, here's my layer 7. All right? And all that was in this packet, in this case, is the payload. Right? Luckily, what I get to know when I look at the UDP protocol is I get to see, oh, okay, 48. Right? So I'm looking at 48 bytes. And here it is. It starts right there, and those are the 48 bytes of the packet. In that particular packet is I find my query. Okay. google.com.kilgore.edu. That's not very good. So I'm probably going to expect that there's going to be no answer. I got kilgore.edu, but whether or not that's actually going to get me anywhere, I don't know. So finally, I sent another one. I have google.com. Responses in packet 8469, which is the next packet. Here's my answer. Right? It tells me the request. It tells me how long it took. So I have the ability here to see that this is the application layer protocol, and it is actually working. All right. And I can see that I'm using 2 different applications to make that happen. So going back to our little chart here, using DNS. Now WFTP, what does it use? It's an application. WSFTP is an application, that's its name. All right. And I think it was originally wiresFTP. But it uses the FTP protocol. File transfer protocol in order to send and receive data. And it sends and receives a packet of data. There are actually 2 channels, and this is an interesting protocol. None of the other ones do this, but FTP operates in 2 channels. It has a control channel and a data channel. So I'm going to show you a little bit about that here in our demo. We've looked at the DNS traffic, and now remember, in DNS, we had our transport layer, and we basically passed that right up. We didn't do any type of error correction, not error correction, but any type of transmission correction at this layer. We simply passed it up to the application. So it's a UDP packet. If there would have been an error in that packet and it would have made it to me anyway with some corrupted data, I probably would have known that. But if it would have been delayed, for instance, that chain of DNSs that we saw, that would have been felt by our application in this case. But so let's look at FTP real quick. It used to be, I'm going to close this details, and I have a website here that I looked up, and I demoed this in class the other day. It used to be that if I went and I put in an FTP server in my browser, notice that instead of doing HTTP for hypertext transfer protocol, I'm going to use FTP, which is file transfer protocol. And my browser, there's probably a way to turn it on inside the settings somewhere. But the browser doesn't support natively. It doesn't support FTP connections, mainly because FTP connections can transmit files that have viruses. So it's just a security. What I don't want to do is basically trick someone from a web page to clicking on an FTP link, and then they get to a website and download a file. What I want to do instead is, if I have that service, is I want to go ahead and run the application directly. So what we would do, and we could still use FTP. There's probably a chance that I could turn it on in my browser settings. In Ubuntu server, which runs Linux, it's very difficult to turn on an FTP server. But so here's what I can do. Because Windows Explorer is an application, just like anything else, right? We could actually build us a little Windows Explorer is an application. What application layer protocols does it support? Well, it supports network file sharing and FTP, right? So I'm going to show you that. So remember what I did. I copied that FTP server address from here because it never came up in my browser. Now I'm going to click here, and notice I get, for that particular pathway, I get a URL for it. It's two backslashes that it starts with. It's not a transport or a transfer protocol, but it's a file path. But if I paste my clipboard in here, notice I'm pasting a transfer protocol URL, file transfer protocol, the 2 slashes that are forward slashes, and the server. So I'm going to press OK. Now, it used to be that with FTP, I could log in anonymously, and all I had to do was provide my email address. So servers have actually turned that off these days. So what they did in this particular case was they have a web page. This is this particular FTP server actually is all the way in Europe, so it's across the undersea cable. And the reason why I picked this one is because we're going to see some features of the TCP protocol in this. Now remember, we got two different data channels that are gonna happen, and I'm gonna show you both of them and why both of them are important. Okay. So, but at first I have to log into this FTP server. So I'm gonna go ahead and do that. My username. I can't log in anonymously. I gotta use some credentials. But obviously, it's not that secure, okay, because they put the credentials on the website, which is pretty smart. All right, and so I'm going to go ahead and log in. All right, so now I've executed a command, and let me just go back and filter my protocol FTP. Now, let's see what I got. So I'm going to go ahead really quickly. And for one thing, let's notice this just really quickly, right? So this is a protocol that is, first thing I want to show you is that when I look at FTP packet, notice that I have a TCP header right here, right? So all of a sudden, once we put that TCP header on, we're falling under all of the good things about TCP and all the bad things, right? So it's possible that it's going to be kind of slow, but it will, whatever we transfer will be error-free, or should be error-free. It's still a good idea to check for errors. Or a lot of times what we're doing is we're checking that something hasn't been modified. Okay. But so this is my TCP header. I have it here. I am using TCP to transfer this information. I want to show you what this session looks like. So we're going to look at this data layer real quick. And I'm going to follow the stream. And so this looks like my browser tried to log in. See how it used the password of anonymous and IE user? Okay, so that's probably my browser, user anonymous. So we're not going to look at that stream anymore. I'm going to look at FTP only. And the other thing that I'm going to do, and I'll just show you this really quickly, because I have this stream index, I'm going to go ahead and right click on it and apply it as a column. Now I can easily take a look at my packets that are filtered, and I can see when we have a different conversation. So this 196 is one conversation, 197 is another one. I'm going to go ahead and follow the stream. Here's my anonymous and my IE user. So at some point, I logged on to this server. We're going to find it. Oh, maybe it's 206. Yeah, there we go. Stream 206. I'm going to follow the stream, right? Now, there we go. Look at that. I have my username, my password. Now, what's happening is each time that this server is giving me a 200 code, that is a success code. Okay. The 300 is input, And if we had another code, in this case, let me close that and look at the other stream. User cannot log in. Notice that in this particular case, the error is can't log in, and the code's a 500 code, right? So we can really get some good patterns here by just understanding the way this protocol works right away. 200 codes are success, 300 codes are input, 500 codes are errors. All right. So I can really, if I know that, I can really get to the bottom of everything really fast. But I can see what this protocol is doing, right? I'm putting the password in here. I get a success response that says the user's logged in. Now I give it some commands, right, that actually issues in this case, what I'm doing is I'm setting an option to use the UTF-8, Universal Character Set 8 on, turning that on, right, and then it gives me an OK. Right, and now I look at some other commands, site help, right? And it says the following site commands are recognized. Right? Dir style and help. And I chose to do the print working directory. So this is basically my control channel. And if I go in here and if I dig around in this FTP, we will be able to see this thing actually work. So I'm going to go up a folder. No, I can't. Okay, I'm going to go in here. It's possible that I have changed streams by this point. No, I don't see it. So I don't see the directory listing here, but I'm going to go ahead and open up one more directory. Oh, I'm still looking at that stream. Okay. Let's look at FTP one more time. And we're going to look at stream 207 instead. Because apparently we try to log out and log back in. And now I'm going to look at the next one here. Okay. Here's our next stream, and I'm going, as you can see, it's showing me the command successful. I'm going into passive mode. It's sending me some information. I'm choosing the list command, right, which is a command to actually give me the folder structure, right? And so if I wanted to go in and actually download one of these files, I can probably do that. What this is, by the way, is a European car navigation, or not car, a sea or a ship navigation software. So I'm just going to download, I have some PDF documents here this morning. A pretty big file. But what we're going to go ahead and do is I'm going to go ahead and take that file. I'm going to go back to my temp folder, and I'm just going to paste it in here. Okay. Notice that we are using the application to copy that file. And if I look at my FTP, what I will do, and I'll show you this. So FTP first. All right, and here's my stream 270. Okay, now we're going to look at that real quick. Follow stream. And now we have all of our responses. So I am going to actually, it says enter passive mode. I'm getting the size of the file. Here's my file size, and it says retrieve. Right? This is the file that I'm actually asking for. Now right here is where we open the data connection. All right. So 21537 is where I open the data connection, and I'm just going to clear this filter. There's my data connection. Now, what I did next was I opened an FTP data connection. Okay. It said that that connection was already open, and so I began to use it to transfer the file. So we're going to look specifically at that stream. Okay. And this is the actual file that I downloaded. When I was in class earlier, I downloaded a PDF file. And one of the things that we noticed when we opened that file is it asked for a password, but it wasn't password protected on the inside. So notice that this is the, we're still downloading this file, I think. Let me see. No. But it is pretty big. It's 38 megabytes in size. So I have this file here, and it's loading it up. This is the actual binary copy of the file. But that is the FTP data transaction. And so one thing to notice is that each one of these packets is the very same size, right? It's 1,418 bytes. I'm breaking this thing up into consistently sized packets. So I got data that's 1,418 bytes. I have an overall packet that's 1,472 bytes. I have an Ethernet header with 14 bytes in it, an IP header, and we should be able to get some actual information about the length of the header right here. The header length 20 bytes, right? That's ensuring that it really is an IP header, right? It's not some other thing. And we have our TCP header, which gives us information about um, the packet. It's also 20 bytes. It gives us that IP address port number. And it is pretty interesting when you think about it that we have a. Oh, I want you to don't miss this one. Okay, so if I have a TCP an Ethernet frame header, right? Uh, what all do I have in that frame? Right, I have a 6-byte MAC address, a source and destination MAC address. Right, so that's 6 bytes here, 6 bytes here, and a frame check sequence. Okay. And a start byte. It's so very interesting that my IPv4 address, right, it happens to be four 4 bytes here, and then a 2-byte port number. Right, this is my socket that I'm going to use. Right, also 6, 1, 2, 3, 4, and then 5, 6. Right, 6 bytes as that whole thing. So it's just interesting, right? That it happens to be the same length of the MAC address. So moving on, I have what I see here is that my packets are all the same. So as I begin to split this up, I end up also having some issues right here in the file. Now, when I look at this, this is my TCP in action. So what actually happens right here, and I'm going to go ahead and stop. I don't need this. I don't need this file. So I'm going to log out. I'm going to log out of the FTP server. Okay, so what I get is I get some warnings on these packets, and I'm going to go into my expert mode and actually look at them. All right, here's my warning. Transmission control protocol, sequence acknowledge analysis. It says it was a duplicate acknowledgement. Now, that's not true for everything. I'm going to look here. There may be one that's different. Let's see. That was a duplicate acknowledgement. That's a duplicate acknowledgement. Earlier, what we were seeing were some out of order packets. It said possible out of order packet. Now, what we have to remember is that this data is coming from the UK, right? So when we look at our world map, right, and we really look at this, and I got to remember I'm right over here in Longview, and I'm going to head to Dallas, or I may head over to Shreveport. I'm not sure exactly where I'm going, but I think I'm going to head to Shreveport. And then I'm just going to go straight to Atlanta. Probably I'm going to go to Dallas and then Atlanta. And I'm going to hightail it up the East Coast to New York. And then I'm going to go all the way under the ocean to who knows how many repeaters. And I'm going to find my way over here. And I'm going to come on shore at Ireland. Or I'm going to come on shore at Jersey. I'm going to jump over the English Channel, right, and find my server in the UK. And then I'm going to go back. Right. So there's going to be some errors in that long journey. It's very long, very long. So it could be very common that we see issues in the packet, and in this case, duplicate acknowledgments, but also possibly some out of order packets. That's pretty normal. And the interesting thing about it is that TCP handles that very well. And that's all part of the application layer and how it works. We're going to look at this. I don't see anything here that would be, these are errors that could happen. But what I'll see is, in this case, just errors in the TCP stream 274. But here's my out of order packet. Okay, we'll look at that. All right, so here's an example of, these are all the packets that were read out of order. And what could happen with that? It could be some delay. It could be a missed packet, a drop packet. It was going a long way, right? So there's a very good chance that we're just going to have some out of order packets, okay? And notice that what we get is, it's basically looking for this one packet. And as you can see, these sequence numbers are adding up pretty fast. So I'm transferring a lot of bytes over this medium, and it's going, and it's basically acknowledging every single packet. Right. So probably what's happening is, because of the distance that this transmission is actually traveling, it is seeing some very high delay, and so it's responding. Excuse me. It's responding that it didn't receive the packet, and then of course it receives it, and then it does it for every single packet in the transmission. But eventually, it receives them. So it's just because of delay, and that is it's probably a failure on the server side to not actually push a congestion bit in the packet. If they had done that, it would have worked out a little bit better. But now you've seen the TCP layer in action. You've seen 2 application protocols in action. 3 actually. 4 actually. The ones that you've seen in action are the HTTP protocol with SSL, the DNS, the FTP data, and I'm going to show you one more. And that is the imap data. Imap is a protocol that is used for email. So Gmail uses IMAP. So if I go to my Gmail account, I'm not going to get any IMAP traffic. None. And the reason why I'm not is because the IMAP traffic is between this web server that generates this web page and Google's mail server. This browser only shows me web traffic, and it shows me Google Gmail's interaction with their IMAP mail server. Okay, so we just don't see that there. But if we were able to look at an IMAP interaction, I'm going to show you what that looks like. I'm just going to go here really quickly. And I'm going to, I don't know if I'm going to find that file. Let me look here. Let's see if I can find it. Yeah, here we go. I'm going to put it in my documents folder. By the way, if you want to see traffic, you can go to Wireshark's site, and you can put in any protocol you want, and it will show you the traffic. So if I want to get a sample FTP, I can do that. But this is the IMAP, and I'm going to load it up, open it up in Wireshark, and we can see it really quickly. No. Wrong file type. So we're going to go to our downloads, and I'm going to show in the folder, and I'm going to right click on it, and I'm going to shoot open with, and I'm going to choose Wireshark, but let's see. Okay, now I'm going to load up my capture file in Wireshark. And the Wireshark people made it pretty easy for me to actually look at this. They cleaned it up really good. They didn't keep everything private, but if I follow the stream, right, this is my IMAP session. So if I were to go on my mobile device and actually look at use an app to get to Gmail, and I use, so for instance, okay, let me give you an example. If I opened up my application that's called Mail on my iPhone, the first thing I would have to do is create an account. So once I go into that application and I put in the settings for the server information, I'm setting up an account profile. That server is going to use the IMAP protocol to transfer message header information over to the app called Mail on my phone. This is a transcript of that communication session. So basically, here's what happened. Is I'm announcing myself and I'm asking the server, what capability do you have? And then it tells me, these are all the things that I can do. Right? So because I know the protocol, I know the things that I can do and the things that I can't do once I see this list. All right. So now I'm going to log in, and now I'm going to say, show me the messages. Right. So we're going to choose. We're going to actually show, in this case, a list of folders. It's going to select inbox, and then here is the exist and the recent messages. And eventually what happens is I say, hey, give me, I use the fetch command, and I say, give me the first 13 messages, 1 to 13. And that's exactly what it does, is it proceeds to give me the headers of all of the first 13 messages. And that's generally enough to show it on my device. Right? I don't need to download everything. I just need to download enough to know whether I want to get the rest of the message. So I get these first 13 messages. And now I go, oh yeah, this is no operation, right? It's just something that happened. It's probably waiting. So there's a keep alive here that submits a no op. And it basically says, don't do a whole lot right now. All right. And actually, if you can see my screen, when I click on the first, when I do the first one, when I get the response, the time code 640, when I send that no op, I'm waiting about half a second. Roughly. And then I do it again. Now in this case, I've waited 5 seconds before I sent the next no operation. Right? There's been 5 second delay. The next thing I do is this is 3 seconds later, right? Before that next timeout, is I send me message 12. And this is what it does. It sends me message 12, and I've probably given it some kind of parameter to telling me what format to send it in, okay? And so it gives me the message, the whole thing. But you see, if I did that, and I use, for instance, post office protocol, I would be getting the contents of my whole mailbox. And I'd have to figure out how to deal with storing it. Now, one thing I'll show you, one more thing, is when I go, and I like looking at this. Time delta for previous displayed frame. And I'm going to apply to the column. And I like looking at it because it tells me things, right? Especially when I look at my no operation command. And I can see, okay, it was 4 seconds. Then I sent another one. And that was 0 seconds. Then I sent another one. It was 3.8 seconds. Then another one. Right? So it's a keep alive is what's happening here. How many times am I going to send that? I'm going to send it as many times as I need to in order to keep that connection alive while I'm checking my email. But the great part about it is it's a really small little command. It doesn't take a lot. Okay? All right. And then I got some other stuff that I can do with this, so I'm not going to go over the whole protocol, but you get the idea. It's transactional. It's really very, very similar to FTP in its transactional way. So that's enough. We've looked at several different application layer protocols. We've actually used Wireshark to look at that information. We've downloaded a demo from Wireshark. We've verified that our Gmail doesn't actually send out imap. And we've used DNS and HTTP and HTTPS. I hope you've enjoyed this demonstration, and I want to thank you for your time and patience. And I will be signing off. Thank you very much.